Welcome to the second part of the marathon on arithmetic and geometric progressions. We're going to do the second worksheet today. It says the first and second terms of an arithmetic progression are 1 over cos square theta and minus tan square theta over cos square theta respectively, where they show that the common difference is minus 1 over cos 4 power 4 theta. Now, if you haven't done trigonometry already, you will have to do trigonometry in order to understand this. So I'm going to solve this. It says show that the common difference is 1 over cos 4 power 4 theta. So if they are the first and second terms, I can simply say that the common difference is the term 2 minus term 1. That's a common denominator for me. So I can then say that the numerator becomes minus sine square theta over cos square theta minus 1 divided by cos square theta. This becomes minus sine square theta minus cos square theta because I take a common denominator and I change this to a multiply. That gives me minus 1. If I factor out the minus 1, it gives me minus sine square theta over cos square plus cos square theta over cos power 4 theta. And then I remember my identity. I can say that our common difference is minus 1 over cos power 4 theta. It says then find the exact value of the 13th term when theta equals to pi over 6. So I think that's simple. The 13th term is a plus 12d. A is 1 over cos square theta. So I'm going to write 1 over cos square pi over 6 plus 12 times. That's what I've proved. So minus 1 over cos power 4 pi over 6. Okay, and that should give me a final answer. Let me get to the final answer. I will use my calculator to calculate each of these individually. I don't want to mess up my calculations by taking writing the entire thing in one go, because the squares and everything might mess it up. So this comes out as 1 over 4 over 3 because I've already done 1 over this, and power 4 gives me 16 over 9. So plus 12 into minus 16 over 9. That should give me 4 over 3 plus 12 into minus 16 over 9. That gives me minus 20. That's the correct answer. Moving on to the next question, we have the first and second the first, second, and third terms of a geometric progressions are this and that. Show that K satisfies this equation. Now we've discussed this before, that whenever you have a question that says that has an unknown in addition to what you typically have as unknowns, what you simply do is you take the idea of the common ratio, that term 3 divided by term 2 should equal term 2 divided by term 1. So I can say that 6k minus 4 over 5k minus 6 should equal 5k minus 6 divided by 3k. Cross multiplying this gives me 3k into 6k minus 4 and 5k minus 6 into 5k minus 6, which is 5k minus 6 whole square. Let's write the whole square. So I get 18k square minus 12k, 25k square minus 60k plus 36. I've done a whole square, a square plus 2ab plus b square. So that gives me, after subtraction, 7k square minus 48k plus 36. That's the first part of the question. The second part says find, showing all working necessary, the exact values of the common ratio corresponding to each of the possible values of k. So I need to solve a quadratic and say that 7k square minus 48k plus 36. Now on the exam you are required to do a quadratic formula. The rest of the things that you can do on a calculator. So minus b plus minus root of b square minus 4ac over 2a. So 48 plus minus, I don't really need to calculate any of this. I can just put it on my calculator now. 7 minus 48, 36. So I'm getting k as 6 and 6 over 7. I want the common ratio in both cases. So the common ratio is basically term 2 divided by term 1. So 5k minus 6 over 3k. So I'm going to first use k equals to 6 and say that r then becomes 5 into 6 minus 6 over 3 times 6. So that gives me 30 minus 6 is 34 over 18 should give me 17 over 9. No, I think I might have made a calculation mistake there. Oh, 24 over. That gives me 4 over 3. And when I have k as 6 over 7, I can say that r is then 5 into 6 over 7 minus 6 into 3 into 6 over 7. I'm going to use my calculator to do that. And that gives me minus 2 over 3. That's part 2. Part 3 says one of these ratios gives a progression which is convergent. Find the sum to infinity. So remember that convergent basically means that r should be between minus 1 and 1. Therefore, it's this one that gives you a convergent geometric progression. I'm going to say that sum to infinity is basically the first term, 3k, over 1 minus r. So I'm going to say that 3 times, this one was 6 over 7 over 1 minus r. That gives me 54 over 35. Is that the right answer? Yes, that is the right answer. Okay, that's question number 2. Question number 3 says two heavyweight boxers decide that they would be more successful if they competed in a lower weight class. For each boxer, this would require a total weight loss of 13 kgs at the end of, so a total weight loss that tells me it's talking something about the sum. At the end of week 1, they have each recorded a weight loss of 1 kg. So that's the starting term, and they both find that in each of the following weeks their weight loss is slightly less than the week before. Okay, boxers 8 weight loss in week 2 is 0.98. It is given that weekly weight loss forms an arithmetic progression. So D should be 0.98 minus 1, which should give you 0.02 in the negative. Write down an expression for his total weight loss. I'm asking you for the total weight loss next week. So that means n is x over 2, 2a plus n minus 1 times d. I can leave it like that, or I can choose to simplify it. Now, some people might question if there's a minus plus both. No, there isn't a minus plus both. There's just a negative sign. This is from the marking scheme. So the marking scheme will give you marks. This one mark, even if you wrote the wrong common difference, which means if you wrote plus 0.02. So that's one thing that you need to be aware of. Okay, I will simplify it a little bit because I think I might need it in the next part. So that gives me x over 2, 2.02 minus 0.02x. Okay, then says he reaches a 13 kg target during n weeks. Use your result to part 1 to find n. So I think that's simple. I can just say that 13 is the sum when x is n. So 2.02 minus 0.02 n. This makes a quadratic equation of sorts. So I get 0.02n square minus 2.02n plus 26 equals to 0. Putting this on my calculator, let's see what I get. I get two answers. I'm getting n equals to 85.85 and I'm getting n equals to 15.14. Now, as I've emphasized in the lecture videos, you take the smaller n when you have a common difference that's negative. That's because you reach the target and your calculator or your formula doesn't know that you need to stop the arithmetic progression at that point. So the arithmetic progression would have stopped on term number 16, which means 16 weeks. Okay, on 15 weeks he would be below 13, but he wouldn't have met his target. Okay, then boxes B's weight loss in 2 weeks is 0.92, and it is given that his weekly weight loss forms a geometric progression. So I will need the common ratio, so that's 0.92 divided by 1, that's 0.92, that's term 2 divided by term 1. Calculate his total weight loss after 20 weeks, so 20 over 2, 2a. Oh, that's my bad. This is a geometric progression. Let's apply the geometric progression formula. So it's a 1 minus r power n over 1 minus r. So 20 terms is 1 times 1 minus 0.92 times 20 over 1 minus 0.92. Okay. That gives me 10 point. I might have calculated this incorrectly. Let me just check. Oh, okay. Um, okay, so the answer is 10.14. And that's how much he's lost. This answer is for the next part. Actually, it says and show that he can never reach his target. That means that even if I were to keep adding the weeks together, I would see that the sum never reaches 13. Now the only way of proving that is to calculate sum to infinity. So let's say he was dieting for an infinite number of weeks, which is unrealistic, but that's how you would prove it. Okay, you would say 1 over 1 minus r, so 1 minus 0.92, and that gives you 12.5. So even if an infinite number of terms existed, which means that he was dieting for infinite number of weeks, he would still be losing only 12.5 kgs if he was following a geometric progression. Going on to the next question, it says two convergent geometric progressions P and Q have the same sum to infinity. The first and second terms are 6 and 6r, which means that the common ratio is 6r over 6, which is r only. The first and second terms of Q are 12 and minus 12r, which means that the common ratio in this case is minus r. Okay. Find the value of the sum of the common sum to infinity. So the sum to infinity of P is equals to the sum to infinity of Q. So I'm going to say that A over 1 minus R should be equals to A over 1 minus R. Its R is also negative, so there's a negative sign here as well. When I multiply this, I get 6 plus 6R equals to 12 minus 12R, and that gives me 18R equals to 6R equals to 1/3. That is the common ratio. It's not the common value of the sum to infinity, so the sum to infinity is going to be 6 over 1 minus 1/3, and that should give you 9 if I am correct. 6 divided by 2 over 3. Yeah. Okay, then this one is a little tricky because it involves trigonometry. Look at this carefully. It says the first term of an arithmetic progression is cos theta, and the second term is cos theta plus sine square theta. It says where theta is between this, the sum of the first 13 terms is 52. I know that the formula for the sum is n over 2, 2a plus n minus 1 times d. uh, is 52. Now the first term is fine and there are 13 terms, so I'm going to write 13 over 2, so 2 cos theta. Now what is d? D is the difference between these two. Now you see the difference between these two is actually sine square theta. So I'm going to write term 2 minus term 1, which is the common difference. So that comes out as sine square theta equals to 52. Okay, and I get 8 2 cos theta plus 12 sine square theta equals to 8. Yeah, I think that should be 8. Okay, so I have 12 sine square theta plus 2 cos theta minus 8 equals to 0. Now, for those of you who haven't done trigonometry, this is what you would be doing once you study trigonometry. So I get 12 minus 12 cos square theta plus 2 cos theta minus 8 equals to 0. So 12 cos square theta plus 2 cos theta minus 4. I hope I've done the calculations correctly. Half and minus 2 over 3. So cos theta is half and cos theta is minus 2 over 3. Now find the possible values of theta from 0 to pi. So this one comes up in the first quadrant. This one comes up only in the second quadrant. I have an alpha for cos inverse of half, which is pi over 3. And I have an alpha for cos inverse of 2 over 3, which is 0.841. So I just need to be absolutely sure that I have taken the right signs. Okay, so this would give me 12 sine square theta, 12 sine square theta, and 2 cos theta minus 8, 12 minus 12 cos square theta. Oh, I messed up a sign. This is minus 1 minus 2 cos theta. So this would be minus and that would be plus, which is why I was getting the wrong quadrants. So this is quadrant number 1 and this is quadrant number 2. So quadrant number 1 gives me 0.841 and quadrant number 2 gives me pi minus pi over 3, which should be the other answer, 2.09. I think those are the correct answers. Okay, then there's another trigonometry question. It says the first term of a geometric progression in which all terms are positive is 50. The third term is, so AR square is 32. Third term is AR square. So 50 R square over equals to 32. R square should therefore equal 32 divided by 50. I take a root, so R should be either 4 over 5 or minus 4 over 5. It says positive, therefore this. It says find the sum to infinity. So sum to infinity will be A over 1 minus R. It's 250. The answer is the first three terms of an arithmetic progression are 2 sine x, 3 cos x, and this respectively where x is an acute angle. Show that tan x equals to 4 over 3. So I think I will prove with the common ratio. I can say that the common ratio is the second term minus the first term, or the third term minus the second term. That is the common ratio. What I get is, by adding, subtracting things together, I get 3 cos x minus 2 sin x and sin x minus cos x. Gathering all the sin x terms and cos x terms, I get 4 cos x equals to 3 sin x. And that gives me 4 over 3 equals to sin x over cos x, which is basically tan x. Then it says find the sum of the first 20 terms of the progression. So I'm going to say that the sum of the first 20 terms of the progression is 20 over 2, 2a, where x is an acute angle. So I will need x. Show that. So, okay, so 2a, sorry, 2 sine x plus n minus 1, that is 19 times d. D was 3 cos x minus, I seem to have run out of space. Let me just take this here. 3 cos x minus 2 sin x. Term 2 minus term 1. I don't have my alpha, which is what I'm going to calculate. Quadrant 1, alpha equals to tan inverse of 4 over 3. Tan inverse of 4 over 3 is basically, let's say, exact value. Let's say exact value. 0.9273. Okay, 0.9273. So I'm going to say 10 times 4 sin x plus 19 into 3 is 57 cos x minus 38 sin x. And I'm going to then at the end put in my value for x, because I don't want my answer rounding off a lot. I think this should also give me an exact answer at the end. This should be cos 0.9273, and multiplied by 10 gives me about 137.999, which is 138. I hope that's the correct answer. No, it's not. Find the sum of the first 20 terms. So the first term is 2 sin x, so 2a plus n minus 1, which is 19 times d. 3 cos x minus 2 sin x. Okay, that's a small silly mistake here. This isn't cos, it's sine, which messes up my answer. So 57 cos 0.9273 minus 34 sine 0.9273. Yeah, that gives me 69.999, and that is 70. Okay, on to the next question. It says the first, third, and 13th terms of an arithmetic are also the first, second, and third terms. The first term of each progression is 3. So these terms are actually 3, 3 plus 2d, 3 plus 12d. Okay. And these are actually 3, 3r, and 3r squared. The first term of each progression, find the common difference in the arithmetic. So this is equals to that. This is obviously equals to 3. The next one is 3 plus 2d equals to 3r. And 3 plus 12d equals to 3r squared. That tells me that I have two equations, two unknowns. I can possibly solve them simultaneously. So 3r minus 3d equals to 3r minus 3 over 2. So 3r minus 3 over 2 equals to 3r squared. 6. 3 plus 18r minus 18 equals to 3r squared. 3r squared minus 18r plus 15. R equals to 5, R equals to 1. So 1 obviously gets discarded. You cannot get a geometric progression with a common ratio of 1. So R is 5, therefore D is 3 times 5 minus 3 over 2, 12 over 2, which is 6. Yeah, those are the correct answers as you see them here as well. Question 7 says the sixth term of a geometric of an arithmetic progression is 23. So a plus 5d is 23, and the sum of the first 10 terms is 200. Find the seventh term. So I will need a and d. So I've got to solve them simultaneously. 10 over 2, 2a plus 9d equals to 200. So 2a plus 9d equals to 40, and a plus 5d equals to 23. Okay, solving these simultaneously, I'm putting them on my calculator. Although on the exam you should show me a process of either doing elimination or substitution for that matter. So a comes out as minus 7 and d comes out as 6. So a plus 60 is then minus 7 plus 6 times 6. That gives me 29. Part B, it says the geometric progression has the first term 1 and a common ratio of r. A second term, a second geometric progression has a first term 4 and a common ratio of 1 over r. The two progressions have the same sum to infinity. So a over 1 minus r should equals to a over 1 minus r for that case. So 1 over 1 minus r should equal 4 over 1 minus 1 over r. No, it's not 1 over r, it's 1 over 4r. Okay, 1 over 4r. Okay, then I will cross multiply. I want to find what? I want to find the values of r and s. S is the sum to infinity. So 1 minus 1/4 r equals to 4 minus 4r. Gathering the similar terms together, 4 minus 1 is 3. That gives me 15r over 4 equals to 3. R is 4 over 5, which is 0.8. Okay, and I can calculate the sum to infinity from whichever progression I want. It's going to be 1 over 1 minus r. So 1 over 0.2 gives me 5. Oh, okay, that has gone a lot more than I wanted it to. Yeah, that is the correct answer. Question number 8 says it's again on trigonometry, and then we have two more questions to go. It says the first two terms of an arithmetic progression are 1 and cos square x, respectively. Show that the sum of the first 10 terms can be expressed in the form a minus b sine square x So I'm going to say that the first term is 1, and the common this gives me 9 times cos square x minus 1, n minus 1 times d. Okay, from trigonometry I already know that cos square x can be replaced with something. So it can be replaced with 1 minus sine square x, and there's a minus 9 at the end as well. So this becomes 5 2 plus 9 minus 9 sine square x minus 9. The 9 and 9 should cancel out, and I'm left with 10 minus 45 times sine square x. That's the first part. B. Part 1 says the first two terms of a geometric progression are 1 and 1 over 3 tan square theta, respectively, where theta is between 0 and pi over 12. Find the set of values of theta for which the progression is convergent. Remember that the progression is convergent between minus 1 and 1. Now, for minus 1 and 1, the simple idea is that you calculate the common ratio, which is term 2 divided by term 1. Okay, and that gives you that the common ratio is 1/3 tan square theta only. When I remove this 3, since this is made up of two inequalities, it's going to go on either side. It's going to become minus 3 tan square theta is less than 3. Now, what I want you to understand is that tan square theta, whenever you square something, it cannot be negative. So this lower limit is actually not really valid. This lower limit should be 0 instead of minus 3. So I'm going to say that this comes out as this actually gets discarded on this side. I cannot put a root on there. So I'm just going to talk about this. Tan square theta is less than 3. But I don't have a graph or a method for tan square theta. I have a method for tan theta. And when I put a root, I have to take both the positives and negatives. Now, always when you have the negative, you should have flip the sign, and that gives me tan theta equals to minus root 3. To be honest, this question is simpler since this is just between 0 and 90. If you imagine the tan curve between 0 and 90, it looks something like this. So on 90, it simply goes to infinity. So the curve looks like this. So the negative is irrelevant. When does it cross root 3? That's the question. Okay, so what is tan inverse of root 3? Tan inverse of root 3 is pi over 3. So this value is pi over 3. Can I conclude that theta has to be between 0 and pi over 3 for this to be valid? I am looking at this inequality that needs to be valid. To be honest, all this that I did in the middle was not something that's very relevant. When it tan square theta equals to 3, that's pi over 3. Then the next part says, next question says, in an arithmetic progression is the sum of the first 400 terms and the sum of the next 1000 terms. The next 10 terms is 1000. Okay, so the sum of the first 10 terms is 400, and the next 10 is 1000. Okay, now if I don't know a formula that starts from here, okay, I don't know a formula that starts from here. My formula always starts with the first term. So what I'm going to say is that the sum of 10 terms was 400, the sum of 20 terms was 1400, and that should give me a set of equations that I can then solve. So n over 2, 10 over 2, 2a plus 9 times d is 400, 2a plus 9d is 80, and 20 over 2, 2a plus 19d is 1400. 2a plus 19d should give me 140 only. So can I solve these simultaneously? Yes, I can solve them simultaneously. I'm going to put them on a calculator and get you answers. On the exam, you should again not be using your calculator like I am right now, because you have to show me a method on the exam. Okay, so this gives me A as 13 and D as 6. Then it says a geometric progression has a first term A and the common ratio R, and the sum to infinity is 6. A second geometric progression has a first term 2A, common ratio R square, and sum to infinity is 7. Can I construct two equations? Yes, 6A over 1 minus R and 7 is 2A over 1 minus R squared. What I simply need is a substitution for A or R. I think the A substitution is very easy in this case. I can just replace A with 6 into 1 minus R. So that's what I'm going to do in the next equation. 6 into 1 minus R. So 7 minus 7R squared, 12 into 1 minus R. Again, using my calculator to do a quadratic. 7 minus 12 and 5. I get 1 and 5 over 7. 1 obviously gets discarded. 5 over 7 is my correct answer. To what did I need? I needed the values of A and R. So R is correct. Let's find out A. A is just 6 into 1 minus R. 12 over 7. Oh, there are more questions. It says part A, in an arithmetic progression, the sum of the first n terms is given. Find the first term and common difference. We've done this before. We substitute n as 1 and we get 10. When we that is the first term. When we substitute n as 2, we don't get the second term, but we get the sum of the first two terms. So we get 8 plus 16, which is 24. So that's term 1 plus term 2. 10 plus t2. So t2 should therefore be 24. So the first term is 10. T2 should therefore be 14. Term 2 is 14. That tells you that the common difference is 14 minus 10, which is 4. Find the first term and common difference. We found both. Let's go on to part 2. Part B says the first two terms of a geometric progression are 64 and 48. What should that really tell you is that there's a common ratio involved. 48 over 64 is 3 over 4. And the first three terms of the geometric progression are also the first, ninth, and nth term respectively of an arithmetic progression. So if I know the first two terms, can I say that I also know the third term? It's just 48 into 3 over 4, which is 36. So A is 36. Then it says ninth term. So A plus 8D is 48. Although they were geometric progression terms, I've converted them into arithmetic progression terms. And then I have A plus, I know the nth term. Okay, nth term. Term number n is 36. So I think that's a simple solution. I replace this and I get D as 3 over 2. And when I have D as 3 over 2, I can say that A plus n minus 1 times D, nth term, should equal 36. I have A, 36 plus n minus 1 times 1.5. I think this is a mistake. A is not 36, A is 64. That's what I messed up. So D should be minus 2. D is minus 2. So 64 plus n minus 1 times minus 2 equals to 36. 36 minus 64 divided by minus 2 is 14. N is therefore 15 from this equation. Yes, that's the correct answer. This is the last question on the marathon. It says the first term of an arithmetic progression is minus 2, 2, 2, 2, and the common difference is 17. Find the value of the first positive term. So I'm looking for Tn greater than 0, which means it's a positive term. So minus 2, 2, 2, 2 plus n minus 1 times 17. A plus n minus 1 times d. So that gives me what? 2, 2, 2, 2 divided by 17 gives me n minus 1 is basically 2, 2, 2, 2 by 17, and that gives me 130.7. N is therefore greater than 131.7. So it is the 132nd term that is positive. Do I need to find the value of that? Yes, I want to find the value of the 132nd term. So term number 132 will be A plus n minus 1, 131 times D. That's 5. So that tells me it's a small positive term, which means that it's basically I've just crossed that barrier of having negative terms and then a positive term at the end. Okay. Part B. It says the first term of a geometric progression is root 3 and the second term is this. Okay. Find the set of values for which the progression is convergent. It's a similar question that we've done for tan theta just now. So R is basically 2 cos theta over root 3. And I know that for this to be convergent, R should be between minus 1 and 1. 2 cos theta over root 3. Taking numbers on both sides, this gives me minus root 3 over 2 and cos theta and root 3 over 2. So I've cross multiplied root 3 and divided by 2. Since it's made up of two inequalities, I've done it on both sides. Again, I imagine my curve. Where does my curve go? Now, it becomes tricky when you try to do it directly. So I wouldn't encourage that. That's 90, that's 180, that's 0. Sorry, that's 0, that's 1, and that's 360. Now, for minus root 3 and root 3, I will draw these lines and show you this calculation. Okay, so let's say that's root 3 over 2 and that's negative root 3 over 2. So when do I get root 3 over 2? A positive root 3 over 2 is cos inverse of root 3 over 2. That gives me 5 over 6. Okay, and this negative one would come up in the second quadrant. Okay, for in the second quadrant, what am I going to say? That my angles are pi minus pi over 6. Quadrant 2. So my theta needs to be between 5 pi over 6 and pi over 6. I hope that is the correct answer. Yes. That brings us to the end of this marathon. If you liked the questions, please make sure to like and subscribe. There will be a link to the unsolved worksheet and to the solved one as well in the description. Feel free to download them. And please make sure you like, subscribe, and comment for the next video. I will see you in the next marathon.